we're going to pick up with kind of where we left off today. And again, the net change theorem is really what we'll write it like this, is that displacement is equal to the integral from a to b of v of t dt. And do you remember what we said is true about distance? Yeah, good. A to b of the absolute value of v of t dt. So the next thing I'm going to give you to is the mean value of a function, because we're going to use this during this time. But let's in order to do that, I'm going to need to go to a new screen here. Okay, here's what I want you to do. I have a function f, and I've drawn it over the interval from a to b, and I have the heights from 3 to 7 right now, okay? I want you to look at this function, and if you were to estimate the height right now, what would you estimate the height to be here? 4? Sure. How about the height here? 5? How about the height here? 3.5. How about the height here? 6. Okay, what I want you to do is talk to your partner, and what do you think would be a good approximation for the average height of the function? We just picked out a few, didn't we? What do you think is a good representation for the average height of the function? Come up with an idea. 30 seconds, go. Five, 4, 3, 2, 1. Somebody throw something out there. Let's get 3. 5. Anybody else? What? 4.5. Anybody else? I think those are pretty reasonable. I mean, if you kind of move, don't you agree that up here would be way too much? It never spends hardly any time up here, does it? Without a doubt, like it spends a lot of time right around here, doesn't it? A lot of time right around there. And so the way that we actually calculate the average value of a function, it's kind of crazy how it works out. We actually find the area. So you find what the area is, and you divide it by the width of the interval. That's what you do. That turns out to be the average height of the function. And so the way that we express that using calculus is the mean value of a function is equal to the integral from a to b of f of x dx. So you do the area, and then you divide it by the width, which is 1 over b minus a. And so that's going to be an important piece that we're going to put into play here as we try this problem. Do you have your calculators out? Get them out, ready to go. So we're going to pick up kind of where we left off yesterday. Notice that yesterday we were given a rate function, and we use that rate function to find total distance and total displacement, and we're going to pick up with that right here. It says, use your calculator for the following problems. The velocity of a car is modeled by the function, this thing right there. So notice how yesterday you had a function that you could like find where it crossed the x-axis, and you were able to do it by hand. Can you do that by hand? No shot, right? So we use our calculator. T is measured in hours, V is measured in miles per hour. Again, we're given a rate function. Consider V of t over the interval 0 to 4, and S of 0 is equal to 10. What does S of 0 equal to 10 mean? Starts at a position of 10. At time 0, it's at a position of 10. So like if I'm headed north on I-35, I start at a position of 13. Why? Because Albert Lee is at mile marker 13. Get what I'm saying? And I travel from there. So it starts at position of 10. We all good? All right. So this is exactly what you'll need to write on the AP exam. So you will have 45 questions that are multiple choice. You'll then have 6 questions that are free response. This is your first example of a type of free response question you'll get. Half of your work is free response. Each question is worth 9 points. I'm showing you how to get points on the test. Are you ready? Here we go. Find the displacement of the car over the given time interval. Have we learned what displacement is so far? Yes. It's this guy, right? So I'm going to write the integral from what to what? 0 to 4. I don't have to write out the entire function. The function is defined as v, so I could just write v of t dt. And on your test, that's all you have to write. Since the function is identified, go ahead and just write that. Do you know how to do that on your calculator? Good. Let's take it out. Let's make sure we get the same thing. Because your ability to type things in your calculator can be compromised, happens on the test all the time. First of all, I'm going to make sure I'm working in radians. I am. And now I type in 20. Sine, whoop. Y is equal to 20. Sine of pi t divided by 2 minus 1. Go look at my graph. I can't quite see the top, can I? And that's okay. If you want to see the top, go ahead and increase that value. The important thing is we see from 0 to 4. And can I see from 0 to 4? I can. So if I want to determine this, how do I do that? So I can calculate 7, 0, enter, 4, enter. What do we get? -4. The AP exam will want you to write it to 3 decimal places unless it's a number like that. So this is equal to -4. We must, what's that? Yes. Okay. Don't know. I'll have to look at it. Sorry. Okay, we must put a label. This will be meters. I'm going to go to a different one. We know how to do letter C, don't we? Can somebody tell me what the expression looks like for letter C? Integral from 0 to 4 of absolute value v of t dt. I'm going to show you a trick here. Don't type everything in your calculator. I'm going to go into y equals, and I'm going to do this. I'm going to press enter to get rid of the equal sign. I'm going to go down here. I'm going to take the absolute value of that, and I don't want to retype it all in. Everybody agreed? So here's what you can do. Yep, on the sign, press enter. That way I'm going to focus on y sub 2. I'm going to go to second, catalog, and I'm going to grab absolute value. and I want to take the absolute value of y1. Notice how this is y1. Here's where you get y1 on your calculator. You will use this as time goes on, trust me. So I press variables, V-A-R-S, vars for variables, and I want a y variable. And notice function, and I press enter on y1. So I don't have to retype everything. You're especially going to use this when we get to chapter 6. Okay, I'll do it again. I go second catalog, and I press enter on ABS. It's not analog braking system. And then I grab Y1. Here's where I grab Y1. I press VARS for vars, variables, and I go over to Y variables, and I press enter on function because we're working with our functions. We're not in parametric mode or polar mode. We're in function mode right now. So I grab the Y1, and there I have it. Okay, so I have that. And now as you look at your graph, what do you notice about the graph now compared to where we started? It's always above the x-axis, isn't it? So what you're going to do is you're going to second calculate, and you're going to go from 0 to 4 again. Second calculate number 7, 0 to 4. It's a challenging operation for some calculators to figure out. Some of yours are quicker. Mine has come up with 50.99. On the AP exam, you are allowed to write it as a 3 or round to the 4. You can either just cut off at 3 decimals, or you can round it up. I usually just cut off. Okay, excellent question. First of all, if you look into y equals, right now, because I have this highlighted and this not, it's only showing the one graph. So you got to press enter on the equal sign in order to take that off. All right, here we go. Now it says the average velocity. The average velocity. This is where you really have to start to think about the problem. You guys are really good at like problem recognition. For example, if I write this on the board, if I write 2x minus 3 is equal to 11, you're like, oh, I solve it, right? And if I write x squared minus 2x minus 4 is equal to 0, you say, I'm going to factor it, right? In mathematics, we get really used to problem recognition. What we need to do now is we need to focus on what the problem is asking, okay? So, because this is where we get a difference, and I'll show you right now. Notice how this is asking for average velocity, and notice how this is asking for average acceleration. You see that? So right now, you're going to key in on the word average, but it depends on whether we're asking for acceleration or velocity. So let's do this. Are you given the velocity function, yes or no? Yes. So what you would like to do is you'd like to find the average value of the velocity function. I can find the average value of the velocity function because I have velocity. The way we find the average value of a function is right here, mean value of a function. That is average value. So I do the integral from 0 to 4 of v of t dt. Except, what do I do in front of that? 1 over what? 4. I don't even need my calculator. Because what is the integral from 0 to 4 v of t dt? It's negative 4. See it? So 1/4 times negative 4 is equal to negative 1. What is it asking us to calculate? Velocity. What do we measure velocity in? What should the units be? Meters per? Or miles per? Sorry, I wrote down meters up here and I never should have. So these are miles. We good? All right, let's go back to something we've done before. It says find the position of the car at 2 hours and 4 hours. Here's what we want to determine. Position is equal to, this is something you're going to have to learn to memorize. Do you remember what we used to say about particle motion? The position is equal to the start plus displacement. Let's get rid of the words and let's talk about conceptually, okay? I'm starting at mile marker 20, okay? And it's, say, 15 feet to the door. Mile marker 20. I'm starting at foot marker 20, and it's 15 feet to the door. So how far did I travel? 15 feet. What is my current position? 35. See that? We took the start plus the displacement. You see that? So that's what we're going to do here. We're going to take the start plus the displacement. So time at, or position at 2 hours. So we're going to do 2 hours right here, and we'll do 4 hours later. What is the start? We start at 10 plus the displacement. From what to what? 0 to 2. I thought we were going to 4. This one's at 2 hours. So we're going to go 0 to 2. See that? Of v of t dt. Yes. The position at time 0 is 10. Okay, so 10 plus that. So I go back to my calculator, I turn it on, and notice how this is my absolute value one. So I'm going to go over here, I'm going to take that off, I'm going to go up and press enter on that. That way I'm looking at my velocity function again. I'm going to calculate, and I'm going to choose which one. 7. Zero to 2. A 23.464. So 10 plus 23.464. Otherwise known as 33.464. 33.464 what? Miles. The position at 4 hours. What would my expression look like? Nope. We're going to go 0 to 4. Do we already know the integral from 0 to 4 v of t dt? What is it? -4. So you have 10 plus -4 is 6. Do you think you could do this on a test? Do you understand why people find it confusing? Okay? Your ability to start to understand and think through some of these, and trust me, folks, okay? I don't ask the questions on the test in the same exact order. You have to understand what the question means. So I'm going to try to help you do that with this next one. This next one is the easiest question on the whole thing. What is the acceleration of the car at time 2 hours? How do we find acceleration? The derivative. Everybody agreed? So all I have to do is find v prime of 2. That's equal to the acceleration at time 2. To be clear, I'm not just trying to be neat and organized in my work. I'm showing exactly what they want on the AP exam. They actually release all the answers and the corrected work to all the free response questions the next year. So I get to see exactly what they wanted, and this is the language that they want. Now, if you just write, first of all, they don't care if you write the a of 2 in that situation, but they want to see that you took the derivative. So you're trying to tell them what you were doing. So that's good stuff. All right, let's go to our calculator. I've got the velocity function. It's right there. It's number 1. I've left it in my calculator. I didn't get rid of it. I used 2 different spots to help me out. So how do I do a derivative on my calculator? Second, calculate. Number 6, that's how you do derivative. At what time are we finding the derivative? So I type in 2. I get negative 31.415, and we're finding acceleration. The label for acceleration is miles per hour squared. Miles per hour squared. Are we okay with that? All right, our last one, and it's the one that tends to confuse people. They see the word average, and what formula do you think people jump to if they see average? They jump to this guy, right? So I want to show you the difference between those two expressions. Look at what you're given. Here it says average velocity. True or false? You have the velocity function. True. Here, average acceleration. True or false? You have the acceleration function. You don't, do you? So, when you're asked to find instantaneous velocity, you do derivative. When you're asked to find the average rate of change, you do slope. So these questions are actually more similar than the previous question. Notice how both these are asking about acceleration, right? Both of these questions are asking about the rate of change of velocity. The difference is this is asking for it at one spot. This is asking for it over the time interval. What is our time interval? 0 to 4. So what we want to do is we want to figure out the slope from 0 to 4. Well, that's easy. We do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But don't write that on the AP exam. Write this. How do we come up with y sub 2? We take v of 4. We plug 4 into the velocity function, right? Minus what? V of 0 divided by 4 minus 0. Everybody see that those are related? Great. So I've got to come up with V of 4 and V of 0, and then 4 minus 0. That one's easy. How do I come up with V of 4? Got two options. I could go into calculate and I could grab value, or I could go to my table and type in 4 and 0. You do whichever one you want. Does that make sense? So I've got negative 1 minus negative 1 over 4, which is what? Yep. Which is 0. So 0, and what is the thing that we're trying to find? Acceleration. So what's my label? Miles per hour squared. Good. Good job taking that in. About 25 minutes into that. It's one thing to go over it. It's never good until you actually start to do it on your own, right? So open up your worksheet. Let me show you the difference between these problems. Okay, so the first one should be this problem number 3. Everybody see that? And you have 3 problems that are similar to this, okay? You have 3, 4, and 5. So 3, 4, and 5 are what you want to start working on right now. Note that one of the problems, the questions are changed up a little bit in terms of order. So just try to think about what is it asking. If you need to go back to your notes or reference, so be it. Take some time, see if you can at least knock out the first one. Go.